Welcome back to Made Up of Wires, where we have been decompiling Castlevania Symphony of the Night. I'm super excited to say that we got that last weapon function checked in yesterday. So now weapon 0 is completed. If you go to SOTN.z.dev, you can see the progress on various overlays, and the weapon overlay is now at 100% if we can find the right place to mouse over to get the the percentages. Weapon 0 is now code complete. That doesn't mean yet that it's completely portable or completely done, but it does mean that all of the functions for the PlayStation version have been decompiled. There is a weapon 1, which is of equivalent size, so not all of the weapons are done, but it is a pretty big step, and really appreciate all the help from so many people who have contributed there, and especially roaming right there at the end, figuring out that last function. We've been working on the sword familiar, and I think that's where we're going to continue today. We got pretty close on some functions yesterday. I didn't finish those off, so we're at about 98%. I haven't finished those. I might throw those into the permuter at the beginning of the stream, and then we can move on to something else. Well, Gravity Well, if this is the best part of your day, I appreciate it. Thank you. Of course, the beating of the kids, what could compare to the beating of the children? So I'm going to throw this in the permuter. I didn't look at it anymore yesterday. During the PR for that last weapon function, Ziano pointed out that Sozu pointed out that there was some effects enums that I hadn't replaced, and so I went down a rabbit trail of getting a linter for the effect enums, and that was a little different from some of the other linters that we've had in the past. There was cases where we were doing I think a not equals against a combination of several of the enums, and the linter didn't handle that gracefully. It didn't group the values as it was building them. So I added support for that. It was pretty straightforward, and I think that linter is pretty good. I think the next thing I'd like to do with the linter is make it so that I don't think I'm ready to write a header file parser yet, but it would be nice to be able to at least specify the config for all the different enums, not in Rust, but in just plain text files. So there's a few things that need to be fixed. Let me make sure I'm on the right branch. Nope, I'm not. See how much that worked. I did look at a few things. I'm probably gonna have to clean this. Related to what we were talking about with this function yesterday. So it did appear that there were this sword struct that I'd put in place, that these were XYZ. Originally Z was unknown 8. So I did rename that, and I renamed that in my local repo as well. And yeah, I'm expecting that to, which did it. So then I looked at these other globals that are following this XYZ pattern, and can I make those that same structure, and will that work out as well? Will the addresses be pre-computed? And that was not working, at least in decomp.me. So I'm not sure yet what to do about that. But I will run this through the commuter. This is working as it is. It may work better as if those are structs, but at the moment I don't know if that's the case or not. So I'm gonna start the permuter up, and then we'll look at the next function here. This will be a shorter stream today. The kids have early release, and so activities will commence. That looks like I might have copied something wrong. Oh, drat. When I let's do this. So I'm, by having that function in place without the include ASM macro, I didn't get an extracted version of that function. And so I want to make sure that I have that before running the permuter. Because that's what the permuter uses to check its progress. All right, just a little more. So that should be enough. And we'll let that go and see if it can find anything. And so while we're waiting on that, I am going to find the next function. I am going to comment this out, so if we do get another match, we can get it back in there easily. So I'm looking for the next one in this list. So we're looking for non-matchings. So we were just working on 270. We'll go to F28 next. And just keep continuing on. And maybe we'll learn something along the way that that we can share. I think a lot of those same patterns seem to be appearing. I think my context should be fine. Actually, I'm going to take it from here. Yeah, that should be fine. So, as always, we're going to do the normal things. Give our function the right argument name, and try to determine what these other variables are. So we have these four. They're all contiguous. It does look like this 863C is a primitive pointer. So we know that. What's odd here is we're not getting the right offsets. And that may be similar to what we were seeing before. Let me see if... I don't see that. This does look similar, though, where a 32-bit value is being assigned when we're expecting either 8 or 16-bit values at those fields. So suboptimal, but not the worst ever. This B0 assignment looks like it's going to be up in here. So let's figure out what these offsets are for primitive, and that'll give us some hint as to what these values here are. They do look like 32-bit. I might just assume that they're 32-bit values for now. It does look like a struct, though, of maybe size 4 32-bit values, or an array of 4 32-bit values. This var S0, we can see what it's being incremented by, and it's actually 5 32-bit values. So let's do that. Let's say that 670 is going to be an array of 5. And then these others, we'll use this convention where they're all offsets of that. No, that's not going to help, though, because the decompiler is not going to pick that up. We'd have to put that in symbol table to, and then re-extract. But we can do this for our own benefit, and then just make these 32s. Yeah, I was getting copyright strikes for SOTN recently. Not strikes, but revenue sharing on YouTube, which means no revenue. As minimal as it is. All right, so let's decompile that again. Konami wants to get paid. This is from, just moving on to the next quagmire. This is Nightmare Creatures. Which I always mean to go back to. Nightmare Creatures is like Bloodborne before Bloodborne. So off screen I'm looking at the primitive structure and just want to see what this is. So these are X, Y, U, and V, basically all being assigned at once. And so that tells us what these are. And then there's a fifth here that I don't know what it is. So this is basically a coordinate and then a texture coordinate and then something else. Let's see if we have any references to this last value here. The priority. Okay, so that is actually pretty straightforward. So let's create a struct for that. call that. So now we can go through and start fixing all of these up. In this case, our I is still S0, so I'm going to leave it like that. So our unknown 8 here I did that incorrectly. So these are actually going to be not points. They're going to be quads. I thought we had a quad. Quads of 8-bit values. No? Oh, it's just XY. Because XY are 32-bit. So these are points. This is a 0.16. So this is just going to be chord 0. Sorry, chord 1, 2, chord. And priority stays the same. I don't know if, and I don't think it would happen that doing the assignment to both those would optimize out to the same thing. So I'm going to use low for each of these. And then we can circle back and see if that will make any difference. So just a few more of these. So then down here, we're going to have to do the same thing. And I think we get the same. This time we're using var s1 underscore 2, but otherwise it's the same. I'll move that down below. All right, so now we're compiling, and let's look at what else we have. So we have a goto here for loop 10. That's just our standard loop, nothing too exciting about that. And then we have this block 18. Excuse me, this looks like a just falling after the break. It's a little odd. All of these functions are written in a very different style, it seems like, to other code that we've seen. They get optimized in strange ways. The only thing we need to be worried about is making sure that all of the cases are either falling through or not. As long as they're not returning, that seems fine. There's only 2 cases to worry about, so I think that will not be an issue. Let's make an I. It's a little odd. No, Romy, I'm sorry. I didn't fix the function from last stream. I have it running in the permuter right now. We'll see if we got any hits. Some minor hits, but I didn't look at it yesterday, and I didn't want to spend time just poking around. Yeah, so nothing concrete yet. I'll keep it running though, and see where we get. So yeah, this is just the next sort function. I haven't really been keeping track of this over here. So there's T-page and color lookup table. Getting the order of those will be important. It's a little interesting that this is being written to a global instead of a local variable. That's not common. So let's see. One of these is out of order. Let's try draw mode. Let's maybe move draw mode down. Yep, oh, that's right. A few register issues. I think those will work out. So here we have varus0 and varus1_2. I mistakenly used varus0 in all of these places. I should have been using varus1 because that's going to be our I. We'll just replace that with I now. This addition was part of the index lookup, so I'm not concerned about that. And we'll start our loop. Same as the other. So I think this one, it's easy to say, but this looks pretty straightforward. Famous last words, as always. Obviously, these 32-bit assignments for 16-bit values is funky, but not like the craziest thing ever. As always, though, it's that whatever that last trick is. RA1 here was our our pre-computed offset based on the size. Kind of a funky thing here. That seems similar, though, to other stuff that is bound here. Oh, no, don't die on me. Don't. Well, we get to redo a whole bunch of work. That's okay. What doesn't kill you always reminds you to save frequently. Yeah, exactly. Dig Down Deep says I've jinxed myself, and of course an editor failing is not the worst thing ever. Fortunately, most of this is pretty straightforward. I'll try to get through this mechanical stuff as quickly as I can. I do notice that the match is slowly moving away from 100%, but that's okay. We'll figure that out. I think we should be able to get this last block matched. So I am going to try to do that. This is somewhat concerning, and I might rewrite this for the sake of decomp.me and then come back and change it back. So what's happening here is I've given this a struct, and so GCC is saying, I know that this is a struct, and I know that I'm going to load multiple offsets from it, and it's cheaper for me to grab that address and then do these little additions based on that address, as opposed to recomputing each offset each time. If I change this to a naive array of 32-bit values, and then do the math here, I think this will end up matching better. It's unfortunate, and I don't like it from a implementation perspective, but I got it to match first and then clean up later. So these others are going to be the same. I wish I had block copy and paste in decomp.me. So let's see if that looks any better. It's still doing the same, that same offset computation. Okay, so we'll give it what it wants. And basically all these are going to be arrays, and they're all offset by just 132-bit value. We still have to do the ×5 when accessing them, but we don't have to do this additional addition. And these are all happening up front. All right, I'll come back to this. What GCC is doing is basically pulling pointers to each of these prior to the loop, and then just using those addresses and calculating the offsets again based on those. I'll come back and see if there is something I can do to convince it otherwise. I've never used jet reports. I did use a lot of work with crystal reports at one point in my life. I'm assuming it's the same or similar. I always wondered why access, and maybe access doesn't exist anymore, I'm dating myself, why access wasn't based on Excel, like as a backend. So I think that this B0 assignment is happening in line with each of these. So we're setting RGB in each condition. Let's go down to line 52, and yeah, that's all shaking out. So these are going to be those inline assignments. And our floating point. Sorry, fixed point. All that looks good. Oh, interesting. So you can do Excel on top of, or sorry, SQL on top of a Excel spreadsheet. My wife will be happy to know that Access is nothing anymore. In the one computer science class that she had to learn Access and loathed it. I'm just cleaning up any of these shifts by 12. They're just grabbing the integer value of the PlayStation fixed point values. Let's see where I missed. And then we can rewrite these. So all these are going to fall into a pretty nice pattern. Usually for colors, I like integers as opposed to, or decimals as opposed to text. Let's add one more here. Need to be conscientious of time today. All right, so that gets us most of this block. This addressing up here is going to be wrong. Let me put these back in place like they were. Oh, this actually works. That's a little surprising. I didn't anticipate that working. Okay, so up here we're able to just use these offset arrays. They're all one array. It's when I'm defining the data later, I would define it as an array of these 5 32-bit values. But the way that it's being accessed here is as if it's a 5 independent arrays of 32-bit values, but they're just all overlapping one another. So we have some register issues. So let's see if there's anything, excuse me, anything that could be done about this down here. Let's do the do while trick and see if that tricks GCC into not wanting to grab those values. It doesn't. So what I want to do is something that basically forces this register to be recalculated down here. And I'm not sure what my options are. It's possible that, and I'd have to go back up and fix these up here. If I define this as an array of 5 32-bit arrays, I don't think that does anything for me. Type. Yeah, so we need to convince GCC basically that it can't trust this value anymore. Oh. Maybe these aren't. This isn't where that's what it is. These are not arrays of values. These are pointers to arrays of values. And this multiply by 5. Is that true? Let's treat it like that and see what happens. So if I take a reference to this and say that it's a assign 32, it had way too many parentheses. It doesn't give me anything more. Let's look at this data and see. I'm not seeing what I need to see. It's in SPSS, which sucks. So this is going to be zeros. This may tell us, though, if there's other data here. So we'd expect about 20 of these. And that looks like what there is. With their nails done now. It's a little loud. Okay, so what other options do we have? So we have this array. We can take a reference to this. Oh, roaming, you did. Please share. this is still pulling this value. So okay, I'm gonna back that out. I'm going to try something that I normally wouldn't do. I'm gonna put the go-to back. All right, so that almost gets there. Let's try this. Let's change it to a do while. Yeah, so the do while ends up being the same thing. Problem with my loop is that I forgot to increment I. So what's happening is this the multiply by 5 is baked in. So 5 times 14 would be what, 70? Or sorry, 5 times 4, less than 20. Yeah, so we have two variables, or two GCCs keeping two variables around. It is keeping an I separate from another variable. Sorry. Thank you, roaming. Yeah, I'm just trying to tweak with this. So I was able to force pulling from each of these individually. Let's take a look at your. So the one from yesterday, I think, had a. What did we see yesterday? No, not quite the same thing. Let's look at roamings. I'm gonna have to go in about 5 minutes anyway. So let's see where the difference lies. So we're having problems down here. So this is interesting. So you're loading both of these from offset 22, and GCC chooses the load word. That is wild. And is that the only difference? Let's see, you're at 210. That's the only difference. Oh my goodness. Ah, wow. And let's look at the PSP version. Why didn't I get that in the PSP version? Oh, I must have just been reading the offsets wrong. So we're at line 90 on the PSP version. Yes, I didn't look at the immediate values. And these are the same. I did see that yesterday, and I thought about it mentally. I didn't say it out loud. And this would make them the same. Ah, wow. Thank you, roaming. All right, so we're going to change that to 22. That's going to squish everything up. And we still have an issue up here on line 59. And I can't remember if I've tried reordering those. But that's actually, so we have the permuter running on this. The permuter is not going to catch that. It's not going to catch an issue with the index being wrong. So let's throw this one in there and see what we can, if the permuter can give us anything. Oh, that was it. That was the whole thing. No, it's commented out. Not the whole thing. Got ahead of myself. All right. Go, permuter, go. Let's see what you can see. Let's actually look at the diff and see how bad it is. Not weapon, servant. So yeah, the diff is relatively minimal. So really it's just the ordering of those loads. Yeah, almost as if this is coming second or third. So the 7.8 load is actually is really odd. Yeah, that's right. I think we got it. The game is decompiled. That was it. That was no, I'm kidding. Obviously, yeah, there may be something with this, and yeah, it doesn't help. Really odd. Really odd. Was that it? So would all of these be OC and 10 as well? Oh, wrong. Wrong one. Oh, this actually, yeah, would have helped to look over here. So we do have a unknown 80 is being loaded as a word. No, that's out of order as well. We have a sign extend from V0 to A1. So should this be it? Sign 32. Yes. So we have the wrong signature for this E84. It doesn't change PlayStation. Okay, so we are a little closer though. Thank you, roaming. Appreciate it. Looking in here, line 33. Let's see where that was. 33. It does seem like oh yeah, you do have the whole thing matching. Awesome. Okay, I'll take a look at that off stream. I'm out of time for today. So we were working on the last couple. Appreciate all the help as always, finding some of these matches. So on this F28, the problem we're running into here is that we need some way to force GCC to not cache these the addresses of these arrays. These arrays are overlapping. So it appears that we have 5 values packed as what normally would be a struct. And there are coordinates, 32-bit coordinates. Sorry, 2 16-bit values, x, y's, for each of these. The load is a little strange, but when we move this into a for loop, GCC is caching these addresses into a register and then using offsets into that register. That's not what we expect. So what is the right thing? Not sure yet. It is something a little unfamiliar from what I've seen before. Why is our... I'm going to do this because I can't help myself. So here we're going to be adding 20. And this gives us a pretty close match. This is what I would expect the compiler to produce from a for loop. Why isn't it producing this? I don't know. We'll see. Maybe tomorrow. All right. Thanks, everybody. Thanks for roaming. Gravity Well, Mr. MIDI, good having you all on again today. If you want to know more about decompiling Castlevania Symphony of the Night, get a browser that works. And go to SOTN.z.dev. You'll see the progress. And if you've been watching, you were with us on our journey to getting the weapon overlay code complete. If I can find it on here, it's somewhere. It really exists. There we go. At 100% now. Much of this has been on the stream, so if you didn't see it, you missed out. But follow, like, subscribe, do all the other things, notifications, all that, and you won't miss out in the future. You'll see the servant be completed. Sorry, the sword familiar be completed next. See y'all tomorrow. Adios.